Hey everybody, it's Tony from Adafruit, and this is a quick look at using the Arduino IDE on the Raspberry Pi. So it's something that's been possible if you really knew what you were doing and you knew how to recompile the Arduino IDE. But luckily in the last few weeks, there's a version of the Arduino IDE that you can use on the Raspberry Pi. So they have an ARM processor build of it. And you might hear my cat in the background. She's quite excited about using the Arduino IDE on Raspberry Pi. So I'll show in this stream that it's really pretty easy to use a Raspberry Pi in its desktop mode. So, using the graphical interface to just install and run the Arduino IDE. And I'll show you can hook up different boards. So like we can use Circuit Playground, load up a custom board, load up some custom libraries, and use that to program an Arduino. So really cool, usage of the Raspberry Pi. So it's a great little desktop replacement. Now I'm going to use the Raspberry Pi Model 3 for this, and I kind of recommend that if you want to use the desktop because it's got everything built in. So it's got, networking. You could even use Wi-Fi if you wanted, although I really like using Ethernet. It's a little bit faster and easier, but it's got a little bit more speed than the Raspberry Pi 2, so a little bit faster and smoother for multitasking and things like that. And remember, the Arduino IDE, it's based on Java, so it's not the fastest thing in the world, so you probably want to use a Pi 3. But you could use a Pi 2, it's just going to be a little bit slower. And you could probably use a Pi 0 to make this work, but you're going to need a lot of different things. You're going to need probably networking access because you're going to want to download libraries from the internet. You're going to want it to have like a USB on-the-go adapter so you can plug your Arduino board in, because again, we're going to use this just like a computer. So you'll plug the USB port into the Raspberry Pi that's connected to your Arduino, and then you'll just program it. It'll show up like a normal serial port. So if you've ever used Linux, then you'll see the serial port. So to make that work on the Pi 0, you need all the different accessories, and then on top of that, you've got just a single core 700 megahertz CPU. So it's going to be slow. I wouldn't recommend it, but it would be possible in a pinch if that's all you had to use for this. But I recommend the Pi 3. So let's just kind of dive in. I've got the whole green screen setup going, so we'll overlay me on top of the Raspberry Pi. Let me just change the outputs here. There we go. So this is just the Raspberry Pi, the desktop, and I'm logged in right here. And so I just installed the latest version of Raspbian. It's the 5.10 2016 release. And any kind of modern version of Raspbian, anything since Raspbian Jessie should be good to go for this. And I just booted it up. I resized the SD card so it's using the full size of the card. And I just tested a few things out, but it's just consider this like a blank slate that we're starting with. So to use this, it's incredibly easy. You just want to open up the web browser, and we're going to go to the arduino.cc website. And so if we go to arduino.cc, then this will take us to the website, and it just takes a second. I mean, again, remember, it's not the fastest computer in the world, but this is pretty quick. This is certainly a lot faster and more usable for web browsing than any other Pi that I've used. So you go to the website and go to the download. I just scrolled down. Maybe not as fast as I thought. There we go. We'll go back and click that download link, and this should take you to the download page. And then right here is where you can actually pick. So, previously when you saw the Linux build, there was only a 32-bit and a 64-bit build, and these were for Intel processors. So if you had, Intel little, maybe a Chromebook that you run Linux on, that would work, or just an Intel PC. And it's only in the last few weeks that they added this Linux ARM experimental build. And so that's the key thing that you need, because the Raspberry Pi uses an ARM processor. And so code that's compiled for an Intel processor won't work on the Raspberry Pi. And yes, even though Arduino IDE is written mostly in Java, and that's kind of a platform agnostic language, like it has a bytecode that it interprets, there is some specific stuff that has to be compiled for the platform. Things like the tools that it uses, like the GCC compiler suite. So all of that stuff, you need an ARM build for this. And it's been possible, like if you could clone the Arduino repository and do a full build for it on the Raspberry Pi, which is a little bit of a daunting task, or if you even wanted to go crazier and set up a cross compiler, you could do it. You could build Arduino and it probably worked just fine, because there really aren't a lot of platform specific things that it's dealing with here. But luckily now it's super easy. They actually package it up, they give you this build. So that's what you want. I'm just going to click this, and we'll go into the download for this. And of course, if you want, you can support Arduino. We're just going to download this for now. And we'll grab this. And I should also mention, one big thing, make sure you're going to arduino.cc. That's the website you want to go to get the Arduino IDE that we're going to use. There is the .org, which is the whole separate Arduino, and there's a whole can of worms behind that. But arduino.cc is what you're after. So you can see it's downloading it, and it's just going to grab it. I've already downloaded it once, so I've got a copy of it. Now, one thing I would recommend, so after it finishes downloading, I first tried to unzip it, so it comes as a .tar.exe file. I first tried to unzip that using the GUI tools in Raspbian. Like if you click this and then it opens up a little file manager, and that locked up my system. That did not go very smoothly. So let's use the command line to uncompress this file. So I'll show you. We're pretty much done with the IDE, so we'll just close that out. And let's see, let me just see if I can bump the size of this up a little bit. Let's see if they've got a preference here. Display. Okay, font size. Here we go. Monospace 10. Let's go to 20. So we'll bump, oops, this is the fun. I have two keyboards in front of me. So I connected my Raspberry Pi 3. I have a USB keyboard and a USB mouse. And then I just have it plugged into my Ethernet network right now. So, okay, this should be bigger. There we go. That's a lot bigger. So that should work. Okay. Oops, let me just make sure I'm clicked in here. Okay, so it downloaded it. It put it into my downloads directory. So if I go to downloads, then we should see in here. And I have two versions because I clicked the download again. But this is what we want, this Linux ARM tar. .exe. You'll probably see this version of the file right here without anything extra. Now to unzip this or to unarchive it, it's super easy. And actually I've already unzipped it first, so I'm just going to remove the version that I unzipped before. So I'm just going to remove this directory, and then to unzip it, you just want to run tar xvf and then feed it the name of the file. So this .tar.exe. So I hit this. And it's going to spin for a little while. It's decompressing everything, so it takes it a little while. Remember, the Raspberry Pi is not the fastest machine in the world, so this should work. And let's see while I'm waiting. Oh, a question, did I get the Pi Zero V2? No, I don't have one yet, so hopefully maybe in the next few weeks I'll get one and try it out. But it looks like it's pretty similar to the Pi Zero, just adding that camera connector, which seems like a great addition because now you can do tiny little camera projects with it. And every time I've used the Pi camera, I've really been impressed with it. I haven't used the new camera either. So remember just a few weeks ago, they came out with the V2 camera that's an 8 megapixel sensor versus the 5 megapixel on the old one. So it could be a cool combo, the new camera with the new Pi Zero. So, okay, let's see. Someone's wondering, do I do the screen capture on the Pi? No, I'm using the HDMI output of the Pi is going into a little HDMI capture card. This thing's called the Magewell. Magewell X HDMI, I think is what it is. Really nice little capture cards. They're USB 3.0 and they capture full uncompressed 1080p, 60 frames per second even. They use a lot of USB bandwidth though, so you need to use a computer that has multiple USB 3.0 buses, or else it's going to suck up all the bandwidth that you have available. But I've used two of them right now at the same time, which is pretty cool. One for the camera and one for the Pi output. So they're nice. They're a little pricey. They're around $300 each. But when you're doing this stuff kind of professionally, it's worth spending a little bit of extra money on the nicer gear. So, okay, let's see anything else in here. And I think we're almost done here. So it's uncompressing these .so files. These are DLL files in the Linux world. It's a shared library. So a lot of these have platform-specific code. So okay, so now we're done. So that's pretty easy. So it uncompressed it, and it put it inside of this Arduino directory. I'm using Arduino version 1.6.9. And if you just look in this directory, you'll see a lot of things. So there are a few different tools. There's this Arduino executable up here, and that's actually what we want to run. Arduino Builder is kind of another little executable that Arduino uses internally. I think this is the thing that has all the magic of how it compiles the sketch and uploads it to the board, whereas the Arduino executable I think is probably just the IDE, the Java IDE. This install.sh, I'm not sure what that does. Let's look at it. I've never actually run this script, so let's see. I'm guessing this probably just adds a desktop icon or something like that. Yeah, it looks like it's trying to find your desktop directory and it's throwing some stuff in there. I'm not going to run this because I'm not sure that this is going to work for Raspbian, because Raspbian uses a different window manager. So you don't need to run this install in my experience. Everything seems to be good to go just out of the gate with this. So let's run, just go into that Arduino directory and just do /Arduino. So like one thing to realize, we've just uncompressed it. You're not going to get a nice little desktop icon. You're going to have to open up the terminal, and run a command like this to run it. Maybe in a future stream, we might look at how to add a desktop icon, because honestly, I forget how it works now in the latest version of Raspbian. Ever since they switched to Jessie, I think there's a new place that you have to put little desktop shortcuts. So it's not something that I use very often. I think it's just easier to open the terminal. So you just go in and you run Arduino, and you have to do that / in front of it, because that kind of tells it, run this executable that's in the current directory. And it starts right up. This is pretty cool. So you don't need to worry about doing anything like, installing Java, or any other dependencies. It's all included in Arduino. So it should be ready to go out of the gate here. And let's see, we'll just increase this and we'll bump up the size a little bit. If I go into the preferences, just so it's a little more visible. So let's bump this up to, how about 18? So let's do that, and then I'm kind of in the way of the OK button. There we go. So there we go. So looks and feels just like the Arduino IDE. There's nothing too crazy about it. If I hit compile on this sketch, it's going to go and run the GCC compiler. It's going to make sure it can compile this sketch. Now, by default, it's set up to assume that I'm going to use the Arduino Uno. Let's do that. I've got an Uno here somewhere. There we go. Grab this board. So I've just got the normal Arduino Uno. Interesting, the green screen's kind of messing with it, but nothing crazy about it. I've just got a USB cable connected to it, so we're going to plug this into the Raspberry Pi. So I'm just going to plug it into one of the USB ports, and let's see. So there we go. So it's plugged in, and now if I go up to the Tools menu, we should see. So under the Boards menu here, and it looks like it's a little bit of weirdness with the, there we go, so we'll go back to it. So there we go, so we got Arduino, Genuino, Uno, and then the port, so I want to go down, and you can see it kind of figured out that my ACM0 is where my Arduino Uno is connected, so I'll select that. So I click that, and then let's pick a better sketch. Let's do like the Blink sketch. So let's do Basics, and we'll pick the Blink sketch. And then let's upload this to the board. So I don't need to change anything, just by default it's going to blink pin 13. So let's click upload. Let's see what happens here. Let's see. So this is going to compile the sketch, and it actually compiles faster than I kind of expected, because when you think of it, like, behind the scenes, it's running the GCC compiler, it's compiling all the C code, there's C++ code that it generated, and then it's going to upload it to the board, and it happens pretty quickly. So you can see done uploading. And if I look at the board here, let's see, I might be able to show it. You can kind of see, so there's a little LED that's blinking on it. It's right here, kind of where my finger's pointing. So that's cool. So it works. It uploaded to the board, and there was no drama. I was really impressed. Sometimes when you use Linux and you're using the Arduino IDE, you might hit upload and you might see an error like permission denied. And that usually means that your USB port isn't accessible by the user that's running the Arduino IDE. And it's a really common thing, like in Ubuntu, because by default, sometimes these USB to serial chips don't show up with just your user access. Like, it only allows root access to them. But everything seems to be configured correctly out of the gate on Raspbian to work with these. And you can kind of check that. If I go back to the terminal, and if I look at lsl dev tty we'll just do .star, and this is going to show, here, let's do this, lsl dev tty star, not and, let's do star, there we go. So this lists all of the USB ports on the Pi, and you can see here, so here's my TTY AMA 0 device, an ACM 0 device, actually, ACM 0, that's the Arduino Uno. And this is the important thing. Raspbian assigned it to the dial-out group, and then the dial-out group by default allows non-root users to read and write to it, like talk to it basically. So because of that, then my Arduino IDE, I can run it just as my normal user, and it can access this board. So if you do run into a board where you plug it in and you get an error that's like, hey, I don't have permission to write to this board, there are a couple things you could do. You could run the Arduino IDE as root with the sudo command, but I don't recommend that, because it's going to store its preferences and look for its libraries in a folder relative to the current user that's running it. So when you run it as root, it's going to look for your libraries in the root user's home directory, which is kind of a weird place to put those libraries. So you really actually want to change things and fix it so that your serial port that your Arduino shows up as has access to the non-root user. So you could add it to the dial out group, or if you search on like GitHub or on Stack Overflow, all kinds of questions and answers, you can add a udev rule to switch this. I couldn't find an Arduino that it didn't work with, so I think you'd be okay out of the gate. It seems to have the right rules, but just realize if you get a permission denied error, probably means that you need to set up the device to be accessible. Like, see if you can add it to the dial out group, and you should be good to go with that. So that's just a little gotcha. So that's pretty easy. Now let's go a little more advanced and let's set up the Arduino IDE to program an Adafruit board. So I've got this guy right here, the Circuit Playground board. So we'll set it up to program this, and it's really not too hard. It's pretty straightforward. So I'm going to unplug the Uno, and then let's go in and I'll show you. So to set up the IDE, you're going to want to use the board manager, and to use that you want to go into preferences, because we'll give it a special URL. So if I go down to preferences in the Arduino IDE, it's this additional board manager URLs. And so what we'll do is we'll grab a URL that can add all of Adafruit's boards really easily in one step. So it's actually from this little guide that I visited earlier. And I'll put a link down in the description when this is up on YouTube, so you can just go straight to this. But if you search for Adafruit third-party boards, this will show you a guide basically that gives you the magic URL that you need. And it's under this Arduino IDE setup page here. So if I go in here and then scroll down, it kind of shows you, open up the preferences, and then you want to copy out this little URL. And for some reason on the web browser on the Raspberry Pi, the copy code doesn't seem to work. See, it says error, so that's not going to work. So you actually have to just select it. I have a feeling, because this web browser, it's not like Chrome or anything fancy like that, so it probably is using some clipboard API that doesn't support. But I'm just going to select it, hit Control-C, and then let's go back to the Arduino IDE. And now I can do Control-V, and that'll paste it in there. And so now we're good. And then I'll just move this over and click OK. So that's cool. Now if I go into Tools, Board, and then Board Manager at the top, so this is going to load up the Board Manager system. And you have to wait a second. See, it's downloading all of our platform files in the background there. So this tells you all of the boards that are available. So we'll just kind of move that over. And basically you can see at the top, these are mostly the Arduino boards, so stuff like the SAMD board. This is what their Arduino Zero, M0 uses, really nice little boards. And you can go down to some Intel boards, and then way at the bottom, so we'll see now here are the new boards that I installed using that board package URL. So here's the Adafruit AVR boards. So I'm going to pick this, and it shows you different versions. We'll pick the latest one, and we'll just click install. So this one has Circuit Playground. You can actually see it has a whole list up here of all the boards in here. It's like trinkets, metros, any of the basic boards that use an AVR chip. So something that uses like the 32U4, like Circuit Playground or other boards like that will use it. So that's pretty easy, it just installs, and that's good. And now if I go back to the tools and the board menu list here, you can actually see there are a lot more boards way at the bottom. So there's this Adafruit boards option here, and there's Circuit Playground. So we'll select that. And now let's see. Now I'm going to plug in Circuit Playground. So again, I'm just going to plug in, USB port. Nothing fancy here, nothing crazy. You might be wondering, could you use the GPIO pins on the Pi to program the Arduino? And you can, but you probably can't do it from the Arduino IDE. I have a guide on how to do it using AVR Dude, which is a tool that can use the GPIO pins on the Pi to kind of bit bang the protocol. Good for like if you're building a lot of AVR based boards and you want to like program them all, have like an automated tester and programmer and stuff like that. But not something that's easy to use with Arduino IDE. Maybe somebody has a programmer configured for it, but just use the USB to serial and the bootloader. It'll work great. Okay, so I plugged it in, and now if I go back to the board menu, you can see, and sometimes it's weird, it doesn't render, so we'll just reopen this again. There we go. You can see it figured out TTY ACM0 is my Circuit Playground, so we'll select that, and then we should be okay to go. So I'm just going to try the basic Blink sketch, so I'll hit upload, and then this is going to compile again and upload the code, so we'll give this a second here. But overall I'm really impressed. I mean, it says that it's an experimental build, but I haven't seen anything fail yet. You know, I haven't really pushed it that hard, but I've installed some libraries, installed some boards, and it seems to work. I think it's, you know, pretty solid. So we'll give this a second here, and it's doing its compile thing. The first time you compile for a new board, it's usually pretty slow because it has to compile all of the core files, like all of the basic classes and stuff. And then usually that's cached so that next time you build, it just builds things that changed, like your sketch. Okay, so this is running now. So it's there, and I think if I hold it up, you might see, yeah, it's not really in focus. There we go. So you can see the red light is blinking on this board. So that's pin 13. Okay, so that's pretty easy, not much drama there. And then the last thing, so I'll show the library manager. So let's add the Circuit Playground library, which lets us load up more interesting examples onto the board. So if you go into the Sketch, Include Library, Manage Libraries, and if you haven't used Arduino in a long time, this is something they added in the last year, this library manager. Super useful thing, probably the best change I think to Arduino in a long time. So this has a whole index of libraries, and if we search for just Circuit, then we should see this top one is the Circuit Playground library. So I'm going to install this library. And basically this is like an all-in-one library we made for Circuit Playground because it has a bunch of components. It has an accelerometer, it has NeoPixels, and so you could go through and install each of those libraries individually, but we made this all-in-one library so it's a lot easier. You just install this one library and it gives you access to all the components on the board. So now that that's installed, I can actually open an example for it. So if I go into File, if I do Examples, and then if I go down, you can see here's Circuit Playground. So let's load the VU meter example. This is one that I did last week on a live stream. And so this will light up the LEDs on Circuit Playground based on the volume of sound that it hears from the microphone. So this should be all set up and ready to go. So I'm just going to make sure I have the board selected. So yep, there's Circuit Playground. I've got the right board there selected. So we'll hit upload here and we'll let this go. And this will upload to the board. And hopefully everything should work. And again, this is kind of nice. You know, it's already set up to access Circuit Playground without being a root user. So it's got the dial-out group assigned to it. Everything seemed good to go with that. So no drama there, which is nice. So it's doing its compile thing. But you know, I think this is usable as far as like if you could use this to program things. Like if you're setting up a Raspberry Pi for like a kid to, you know, do some basic computing and learn programming and stuff, I think you could grab the Arduino IDE and, you know, start introducing them to that. It looks like it's going to run just fine on the Raspberry Pi 3. So it's doing its upload thing. And okay, cool, it's done. So now let's see if I hold this up, we might be able to see. So this is my Circuit Playground. So you can kind of see as I talk louder, it lights up more and more LEDs. And if I talk a little softly, then it lights up just a few LEDs here. So it's taking microphone input and then converting it into NeoPixels that it lights up. So it lights up a few NeoPixels here. So a really cool thing. I'll put a link in the description. I did a live stream last week where I made this sketch. I basically ported over this thing called the Amplify and made it work here. But I think that's it. I think, you know, I've basically showed off what I wanted to show in this stream. You know, I called it just a quick look. So I wanted to look at some interesting software. The Arduino IDE, quite interesting software, you know, awesome software that we really love. And it works great on the Raspberry Pi now, and it's super easy to install. Like, just download the experimental ARM build. Make sure you're using the full version of Raspbian, not the light version, because you need to use the GUI to use this tool. And then run it, and it looks like it works. Like, there's no drama here. So if folks have questions, feel free to throw them in the chat. I see one question: can you set the verbose output to see the AVR compiler output? Yeah, you should be able to. Let's try it. Let's see. Oops, I messed up. I've got two mice in front of me. One for my main computer, one for the Pi. So that's always fun. Okay, so let's flip on all the verbose options. So let's turn on compile and upload. So these are always handy to turn on. It tells you more of what the Arduino IDE is doing. So let's see. We'll click OK, and then I'm going to move this up so you can see. And now if I hit upload, you'll actually see, so these are all of the GCC commands that it's running when it compiles the code. Kind of cool to turn this on and just see like how much stuff is compiled. Or if you're just curious, like if you want to run your own, compile your own code for AVR, you could look at their commands. Okay, so now it's doing the upload, and this is running AVR dude, and you can see, yep, you get all the output here, and no drama at all, you know, just uploaded it, verified, everything seems good. So this is pretty cool. It's pretty easy. It's actually easier than Mac OS X, I think, where on El Capitan I always have USB issues with that where I have to reset the board, but Linux is rock solid for me. I've never had issues with that, so that hasn't been too bad. Let's see. And I don't see any other questions in the chat here, so I think we're all good. So yeah, we'll call this a wrap. So this was, let's see, we'll go back to the main view here. So yeah, so thanks a lot for watching. This was a quick look at using the Arduino IDE on the Raspberry Pi. So definitely tune in. I stream a couple times a week. Now the next few streams I won't do. So I usually do a stream on Monday, which I'm going to start calling Raspberry Pi Quick Looks, where I just look at interesting software. And then I usually do a stream on Friday where I look at more in-depth kind of programming stuff. So last week on Friday, I did a stream on basic data storage with Python. So just how to store like program state and sensor data and things like that. This Friday I won't have a stream. I'll actually be out at Maker Faire. And then Monday, this coming Monday, I won't have a stream again. I won't do a quick look. I'll still be out there, just seeing what's going on in San Francisco. But I'll be back the week after. So Friday next week, not this Friday, I'll be back with a new stream. But then also look during the week. I'm doing some more live streams. Like I did a Circuit Playground one last week on Wednesday, and maybe I might have time to do another Circuit Playground one this week. So we'll see how things go. But otherwise, yeah, subscribe to youtube.com/Adafruit. You can watch me watch these videos there, and then watch all kinds of other project videos that we put up on YouTube. Subscribe to twitch.tv/Adafruit. You can watch me stream this stuff live. I stream to twitch.tv. And then you can also see all kinds of other live streams we do. So we've got Desk of Lady Ada. Just last night there was a special late night edition when they had the Pi Zero Revision 2 release, so that was a fun one. But then I'm sure this week there'll be more live streams. Noah and Pedro have Layer by Layer, so all kinds of cool 3D printing stuff going on with that. But yeah, like, comment, subscribe, let us know that you like this content, and we'll keep making it, and hopefully it's helpful to folks. So thanks a lot for watching. This is Tony from Adafruit, and this was how to use the Arduino IDE on the Raspberry Pi. So see you guys later.